Graphing linear inequalities. So there's only one objective in this section, which is to graph linear inequalities. Graph linear inequalities. So let's define this real quick. Linear inequalities in two variables. They're going to be set up in this standard form of ax plus by less than c. And just of note, we put less than in there, but that could be less than, that could be greater than, less than or equal, or greater than or equal. All of them would be covered. And an ordered pair is a solution of the linear inequality in x and y if, when we replace the variables x and y with the coordinates of an ordered pair, it results in a true statement. So let's cover the steps for graphing inequalities, just to review them, and then we have some to practice with. Step 1, we're going to be graphing the boundary line. So these are the same boundary lines that you've been graphing throughout this whole unit. So we're going to just replace whatever inequality our equation came with the equal sign, and then solve it like normal, meaning that we want to find points to graph on the line. So you can do this with a T-chart method. You can do this by finding your x and y intercepts, or you can solve it for y and use your slope and y-intercept to graph it. So first step is to just get the line graphed. Now, once you have a couple points, we do need to connect our points together into a line. So we're going to use a solid line if our original equation came with either greater than or equal or less than or equal. That or equal to means that we are inclusive of the line. We are including the line as part of our solution. We're going to use a dotted line if your original equation came with a greater than or a less than symbol, which means we include everything up into that line, but we do not include the points actually on the line as part of our solution. At this point, we have our line graphed, whether it's dotted or solid, and because we're graphing inequalities, we need to figure out which side to shade. So we're going to use any test point that you want as long as it is not on the line. It doesn't matter which side. You can pick any whole number, ordered pair, just as long as our line does not go through it. And we're going to plug it back into the original inequality. If it comes up with a true statement that some number is bigger or smaller than the other one, then we would shade on this side of the boundary line. So wherever that test point is, we shade. If you come up and your final solution here is false, once you plug in your ordered pair, then we're going to shade the other side of the boundary line. So step 2 is covering how to use the test point to determine which side to shade. So let's try it here with example 1. Graph x minus y greater than 2. So the first thing I'm going to do is I'm going to replace our greater than symbol here with an equal sign. And I'm going to solve this equation for y. So I'm going to subtract x from both sides. Then I'm going to divide everything by -1 to get y completely by itself. So we get y equals positive x minus 2. This is the equation that we are going to be graphing for our boundary line. I can use the slope and y-intercept here. So our y-intercept is -2. Make a point. And then our slope is the +1. That's right here in front of our x. We don't see it there, but it's an understood 1, which means we are going to go up 1, right 1 to make our next point and keep going with that pattern in either direction. Now, before I graph the line there and connect those dots, I'm going to go back to the original equation and remind myself that it was a greater than symbol, which means this needs to be a dotted line. So we can connect these points with a dotted line on your graph. Now for my test point, I can pick a point on either side. I like to pick nice, pretty easy numbers. So I'm going to pick this one right here, 1, 1 as my test point. So I'm going to go back to my original equation with our inequality, and I'm going to plug in 1 for x, 1 for y, simplify both sides, and then check to see if this is a true or false statement. Is 0 greater than 2? 0 bigger than 2? It is not. So this is false, which means because this is a false statement, I'm going to shade the other side of my boundary line. This is where my shading will be. If you're ever unsure with your test point step, you could always check it, pick a secondary test point, and repeat the process, and it should always come up with the same solution. So this is our line with a solid line and shading beneath the line. Example 2. Graph x minus 2y less than or equal to 4. So I'm going to start by rewriting the equation and getting rid of our inequality and putting in our equal sign. Then I'm going to solve it for y. So I'm going to subtract x from both sides. Divide everything by -2. And then this time, just to practice, let's do a t-chart. I like to have my equations solved for y when I'm doing my t-chart. It just makes it really nice to plug in. So I'm going to plug in a 0. If I plug in 0 where the x goes, I simplify and I get -2 for y. If I use a 1, I'm going to get a fraction in here. So I'm going to use multiples of my denominator, which will make our life a little bit easier with a t-chart. So I can plug in a 2. 1/2 times 2 gives me 1. Minus 2 gives me -1. I could plug in a 4. And this gives us a 0. So that gave us a couple points to graph with. So we can get that on our graph. Now before we put on our line, go back to the original. Notice it is a less than or equal to. So that means this is a solid line. So let's make a solid line through there. Now for our test point, we can pick a point on either side of the line. It doesn't matter which side. I'm going to pick one down here just to pick something new. So 1, 2, comma, -3. We're going to go back to our original equation with our inequality, and we're going to plug in 2 for x, -3 for y. We have 2 plus 6. And then we ask ourselves, is 8 less than or equal to 4? That is false. That is not true. So we are going to shade on the other side of our boundary line. Example 3. Graph 5x plus 3y less than 2. So we're going to start by doing our boundary line. I'm going to grab my equation over here and swap out my inequality for my equal sign. And then I'm going to start solving this for y. Divide each part by 3. Now I don't have a great y-intercept value here, so let's do a t-chart. And I'm looking ahead at some numbers that may work or may not work. Let's try a 1. If I plug a 1 in here, we have -5/3 times 1 is -5/3 plus 2/3. This gives us a -1, so that gives us a nice, pretty number to graph with. I'm going to try a 2 and a 3. I'm going to get some weird decimals. Let's try a 4. That's going to result in a -20/3 plus 2/3. We get -18/3, which will reduce to -6. That'll give us at least 2 good points to get on our graph. Now, keep in mind, I looked ahead at my numbers. I knew where this was kind of going. So for you at home, you might try 0, 2, 3, some other numbers and realize that it's really quite messy. And that's totally normal. If you get a decimal answer, you're not going to want to graph with that. So just try another x value. That's the whole point of a t-chart, is you can use any x value you want until you find a nice whole number answer to graph with. Now, in order to put our boundary line on here, let's glance over here. We had a less than symbol to begin with. So this is a dotted line that we need to graph. So a nice little dashed line for our boundary line. And then we can pick out our test point. I always try to make sure I pick something far enough away from our line that I didn't accidentally get too close to the line and it's on the wrong side. So I'm going to pick something right here. I've got 3, 0. And we're going to go back to our original and plug in 3 for x, 0 for y, and let's see what happens. We get 15 plus 0. 15 is not smaller than 2, which means we are going to shade the other side from that test point. Example 4, graph 3x less than or equal to 12. Now you'll notice quickly we only have one variable here. So this is either a vertical or horizontal line. Because we have an x, that means we have an x-intercept, which means this is a vertical line. So this is going to be a line that goes straight up and down. And we are defined by where we are cutting through our x-axis. So if we divide both sides by 3, we get x is less than or equal to 4. And it is a positive 4, so make sure you put it on the positive side. 1, 2, 3, 4. Our symbol that we were given is less than or equal, which means that this is going to be a solid line going up and down. Now, if we pick any test point, let's put a test point right here. This is 1, 0. So if we go back to our original, plug in the 1 from the x. Notice there's no place to put the y. That's totally fine. And we check it. 3 is less than or equal to 4. That's true. That means that we are going to shade the side with our test point. Example 5. We have y greater than 4. We only have one variable, which means this is either going to be horizontal or vertical. This one is horizontal because we are being defined by where we cross the y-axis, which is at a positive 4. We are given the greater than symbol, which means that since there's no or equal to, this is a dotted line. So we need to make that dotted dashed line going horizontally through y equals 4. And then for our test point, we can pick something either above or below. Let's try this one. This is the test point 0, 2. So we go back to our original equation, plug in 2 for the y. Notice there's nowhere to put the x, and that's okay. 2 is not bigger than 4. This is false. So we are going to shade on the opposite side of our boundary line. Last but not least, we have y less than 1/4 x minus 3. So we're going to start by swapping out our inequality for an equal sign. And based on how it's set up, let's do a t-chart with this one. We can plug in multiples of the 4 for our numbers to plug in because we have a fraction. That's just going to make your life a little bit easier. So we could do 0, 4, and 8. If we plug in 0, we can simplify and get -3. If we plug in a 4, we'll simplify and get -2. If we plug in an 8, we simplify and get a -1. So that gives us a couple points to get on our graph here today. I'll at least get just those first 2 on there. And then let's glance back to our original. It is a less than symbol, so that means this is a dotted line. So we're going to put a dotted line through those points. And then we need to find a test point. So I'm going to use this test point right here, 1, 0. 0 goes in for my y. 1 goes in for my x. 1/4 minus 3. So we take a 1/4 away from that. That's going to be 2 3/4 negative. That is not bigger than 0. So that is false. So we are going to shade on the other side of our boundary line.